guide for the chapter 7 test. So you should see for 7.1, all you're going to need to do is verify one of the three identities. I am going to do all three though, just so you can see what's going on. Remember, the first rule is always pick the more complicated side. I see one little fraction here on the left. I see a lot of different terms over here on the right. So I'm going to pick the right. Once I do that, the second way to do this quickly is to turn everything into sine and cosine. So tangent turns into sine over cosine. Since it's squared, these are both going to be squared. I have 1, and then I have a product over here. So tangent is going to be sine over cosine. Secant is 1 over cosine. So I looked at what I have here. I'm going to have to multiply these two things together. So that's going to be sine over cosine squared. And it occurs to me then that I have two cosine squared fractions. So let's get our 1 to have the same common denominator. So multiply by cosine squared over cosine squared, and that's 1. Since I have a common denominator, I can add all these together. So the denominator stays the same when you add fractions, and I'll have sine squared t plus cosine squared t plus sine t. Well, sine squared plus cosine squared, that's a Pythagorean identity. That's just going to be 1. So now I have 1 plus sine t in the numerator over cosine squared in the denominator. And that's what I had. That's what I was supposed to get. So I am done. So you circle it, you smiley it, you something it, so that I know that you are done. The second one that you have the option to verify. So the first thing I did was, okay, usually addition and subtraction is easiest. So I started there, and I went cosecant is 1 over sine, secant is 1 over cosine. And I looked at that and I was like, well, yeah, I can get a common denominator by multiplying them by each other, but that's not going to get me any closer to my goal of sine. So I crossed it out. I abandoned it. And I figured, okay, let's try the other side. So I have a victory V, which you can only make V-shaped. You can't do it upside down. So I break apart and get 1 over sine, and I get tangent over sine. So once I do that, I have 1 over sine. Well, that's cosecant. That's a good start. And then I have tangent, which is sine over cosine, divided by sine. When you are dividing fractions, you are multiplying by the reciprocal. So multiply by the reciprocal, because this is really sine over 1, right? So when I multiply, I'm going to get sine over sine times cosine. So the sines will cancel, and this will just be 1 over cosine. Well, 1 over cosine is secant, and that's what we were supposed to do. The last verify problem. There we go. More complicated side, that would be the left on this one, because the right just has cosine. So I'm going to get a common denominator because I have two terms here. There's this little 1 hanging out here. So the denominator is going to have to be 1 plus cosine theta. So I multiply the denominator by 1 plus cosine theta. What I do to the numerator, I have to do to the denominator, and vice versa. So I have 1 plus cosine x over 1 plus cosine x. It doesn't matter that I change the variable. It's a variable. It can be whatever we want. But anything over itself is 1, so it makes sense that we've gotten that. So let's add everything together. So when we add or subtract fractions, the denominator stays the same, so it's still 1 plus cosine x. And now I have 1 plus cosine x minus sine squared x. Well, that's not something that I can combine. So I'm going to use the Pythagorean identity to make sine squared into 1 minus cosine squared. But I have to remember there's a minus sign on the outside. So I'm going to end up having to distribute that minus sign. So I'm going to have minus 1 plus cosine squared. And that's what I have here. I kept the 1 plus cosine x from the beginning. And then I have minus 1 and then plus cosine squared. Well, 1 minus 1, those are going to cancel. And so now in the numerator, I just have cosine x plus cosine squared x. And you can't cancel anything unless it's either multiplied or you could take it out of everything. And that 1 messes that second part up. So let's take the greatest common factor out of the two things we have left, because then we'll have multiplication. So if we take a cosine out of both of those, which I did, when I take a cosine out of cosine, I have 1 left. And then cosine squared, if I take out a cosine, I have a cosine left. And if you don't believe me, try distributing it back in, and you should have cosine x plus cosine squared x. Well, now I have the whole bottom, and I have 1 plus cosine x, and they're the same, so I can cancel them out. So I end up with cosine x. Remember, start with the more complicated side, turn everything into sine and cosine. Pythagorean identities are good when you're squared, and common denominators. So then we go to 7.2 and 7.3. 7.2 and 7.3 tells you you're going to have to use sum and difference formulas. For number 2, they set it up for us. We plug 45 in for A, we plug 30 in for B, we have our formula. Remember that cosine of 45 is radical 2 over 2, so the cosine disappears. Goes for cosine of 30, sine of 45, sine of 30. Order of operations say we need to multiply before we do any subtracting, so we multiply. A radical times a radical can work, but at this point you cannot subtract radicals unless they have the same inside number. So our final answer is just going to be radical 6 minus radical 2 over 4. Number 3 is a little bit harder. Number 3 says to use the sum or difference formula right up there. I drew an arrow, but not written as a sum or a difference. So we have to find one. And we're going to find unit circle things. So what I did on the side here is I wrote all of my unit circle things. I have pi over 2, pi over 3, pi over 4, and down there that's supposed to be pi over 6. And I wrote them in 12s because that's what I have over here. So pi over 2 is 6 pi over 12, pi over 3 is 4 pi over 12, pi over 4 is 3 pi over 12, and pi over 6 is 2 pi over 12. Well, which of these add or subtract to be 5 pi over 12? Well, 3 pi over 12 plus 2 pi over 12 is 5 pi over 12. So I can have pi over 4 plus pi over 3 equals 5 pi over 12. And then I'm going to have to plug it into the difference formula. The sum formula, excuse me. Looks like my answer got cut off here. Oh, no, it didn't. I went this way. So when you plug it in, we get tangent of pi over 4, which is 1, tangent of pi over 6, which is 3 radical 3, etc. Since we have a fraction and a fraction, I'm going to multiply everything by 3 so that all of the denominators cancel. So I'm going to multiply everything by 3. It's 3 times, 3 times, 3 times. And I get this mess, which I need to rationalize. So I'm going to have to multiply by the conjugate, which means we're just going to change the sign here. What I do to the bottom, I have to do to the top. On the bottom, you'll have the difference of 2 squares, because that's how we set this up. By multiplying by the conjugate, you will get the difference of 2 squares. So 3 times 3 is 9, minus radical 3 times radical 3 is radical 9, which is 3. Up on the top, you're going to have to FOIL. So 3 times 3 is 9. We'll have radical 3 times 3 and 3 times radical 3, which will be 3 radical 3 plus 3 radical 3, which will be radical 6. Radical 3 times radical 3 is 3. So we'll get 12 plus 6 radical 3 over 6. And we could take 6 out of all of the outside numbers. So we will end up with 2 plus radical 3. I am going to get cut off here, so I'm going to start a new video for the second page. Okay, the back page starts with another verify identity. Same rules though. Start with the more complicated side, and I see that obviously is going to be on the right. This one that you're not going to have an option on is going to have a half angle or a double angle, something that is not the Pythagorean identities, and that's what you need to keep an eye out for. Especially since I see a double angle here and I see a double angle here, this is suspicious to me. So 2 sine t cosine t, if I look at my identity sheet, that is sine 2t. Secant 2t, well, the same rules again should apply. I want to turn everything into sine and cosine. So secant is 1 over cosine. So secant 2t is going to be 1 over cosine 2t. This is in the numerator. This doesn't have a denominator, so it's over 1. So I'm going to have, when I multiply across, sine 2t over cosine 2t. Well, sine over cosine is always tangent when they have the same variable going on. So we have 2t, sine 2t, or excuse me, tangent 2t, which is what we were trying to do. We're done. So give me a smiley face. Give me something that says, hey, this is what we were trying to do. Then it gets a little bit harder. Find the exact value of the following given. And in your head, you should say, oh, they want me to draw a triangle. So sine alpha, a, whatever you want to call it, sine is opposite over hypotenuse. And it says it's between pi and 3 pi over 2. Well, if you don't like that, you know that pi is 180 and 3 pi over 2 is 270. They're really just telling you what quadrant we're in. So we're in quadrant 3. Oh, and there's another variable, which means they want a second triangle. So cosine of beta, we have an adjacent and a hypotenuse. That's going to be between pi and 3 pi over 2 also. So that's also going to be in quadrant 3. And I went from Roman numerals to Arabic numerals, but that's okay. So I have to draw my triangles. And just like you, sometimes I make mistakes and try to draw my triangle and I realize, okay, wait a minute, I'm in the 3rd quadrant, so I stretch that out. So I start with A, and I think, yeah, I used A and B here. I didn't bother with the alpha and the beta. So sine is opposite over adjacent. I knew the negative had to go with the 1 because it went down, and our hypotenuse is always positive. I did the Pythagorean theorem. Got square root of 8, which can be and should be simplified to 2 radical 2 that's down here. So 2 radical 2 is our other side. It's going to the left, so it's negative. For B, same concept. It's the same numbers, -1 and 3. The negative is going to apply to the 1 because it's going to the left. And if you do the Pythagorean theorem, since these are both sides, we're actually going to get the same value. This will be 2 radical 2. It is going down, so it will be negative. With that having been said, now we have to plug it into the formula on your sheet. So the sum formula for sine is sine A cosine B plus cosine A sine B. Use the triangle to find the sine of A. So the sine of A is -1 over 3. Put it right there. Don't take sine. Sine of A is -1/3. Cosine of B, do the same thing with the beta triangle. Plus cosine A in the alpha triangle, sine B. And then we multiply. Well, -1/3 times -1/3 is +1/9. -2 times -2 is a +4. Radical 2 times radical 2 is radical 4, which is really just going to be 2, because the square root of 4 is 2, over 3 times 3 is 9. Well, 2 times 4 is 8, and with everything else being the same, we have 1 plus 8 is 9, over 9, anything over itself is 1. So we write that on our little answer bar, and we are done. Number 6 is a backwards problem. I want to say you had one similar to this on your quiz. So we have a problem that matches up with cosine squared A minus sine squared A. And if you look at your identity sheet, that equals cosine 2A. So now, since it's backwards, we'll have to work backwards. Well, what is A? A is 15. Plug it in over here. So we have cosine of 2 times 15, which is cosine of 30. Look on your unit circle, and that is radical 3 over 2, and we are done. Please make sure you look at your half-angle formulas that require you to find what quadrant we're in. Just saying. 7.4. Express each product as a sum or difference. Show all your work. So you have the product of sum formulas. Those were not on your quiz. Those are what you learned after the quiz by just watching the video, and you know that you just need to plug stuff in. So we have A, we have B. We plug it in. A minus B, A plus B. 6x minus 4x is 2x. 6x plus 4x is 10x. You cannot add those together because they do not have the same variable structure. You have to have the same variable with the same coefficient in order to add them together. So this is it. This is the answer. It's done. You cannot put cosine 2x with cosine 10x. The only thing you possibly maybe could do if you really, really wanted to was you could distribute the 1/2, but that's not necessary. If you did, it would look like this. You cannot distribute it to the 2x or the 10x. It would just look like this. But why do more work than you have to? Same thing happens down here. We plug it into the formula. We add a plus b. We do a minus b. We cannot add them together because they don't have the same coefficient of their variable. So we are done unless you really, really, really feel the need to distribute the 1/2. Take a look at the sum or difference to product formulas, but again, they're the same concept. You just plug them in. If you have any questions, email me or come see me before or after school. Good luck.